So let's review solving by substitution. We have two linear equations. How do we know they're linear equations? Because they have an exponent of 1. You don't see the 1, but we know they have an exponent of 1. It's implied. So we need to figure out where they are equal on the coordinate plane. And one of the ways we can solve that is to graph them and see where they intersect. But if you don't have graph paper, always handy, you can solve them another way. And that first way we're teaching you is by substitution. So we need to get one of the two equations in terms of y or in terms of x. And already we have one done for us here in terms of y. And so what we want to do is we want to take this section, this expression of 6x minus 11, and we want to put it in place of the y. So that's why I'm going to use parentheses, because the negative 3 is going to multiply times everything in that y bucket. So the next thing I want to do is I want to rewrite this expression, stop, and put the expression in here, and then continue on with the rest of the second equation. So we're saying negative 2x minus 3y, and y is 6x minus 11, is equal to negative 7. So now that everything is in terms of x, you can see we have a 2x and a 6x, and everything is in terms of x. Therefore, now I can solve for x. So I now will distribute the negative 3 to the 6x, and I get negative 18x. And I'm going to distribute the negative 3 to the negative 11, and get plus 33 is equal to negative 7. I can combine my like terms, and I get negative 20x plus 33 is equal to negative 7. I now need to subtract 33 to both sides. I get negative 20x is equal to negative 40. Divide by negative 20. X is equal to positive 2. Negative divided by negative is a positive. 40 divided by 20 is 2. So this helps me find my x coordinate. However, we need the y coordinate. So I don't go up to any kind of simplified expression where we have it all in terms of x. I want to go back to the original expression at the very top, the ones that were given to us on the worksheet. We go back into the original problem. So I'm going to go back to the first expression, y equals 6 times x, which in this case we solved for was 2 minus 11. And y is equal to 12 minus 11, so y is equal to 1. Therefore, the solution to our system where the two equations meet is 2, 1. What happens when we're given one equation where it just says something simple like y equals negative 2? Well, it means that half of our work is already done for us, because remember, we're trying to find the x, y pair, and that means we know that y is negative 2. So all I have to do is sub in for y and solve for x. It's that easy. Okay, Mrs. Evans, well, what if I have two equations, neither of them are written in terms of y? Does that mean I can't do substitution? No, it means you just have to rearrange one of the equations. And the second equation here looks like a great candidate. And I know that your tendency is going to want to be to put it into a y equals format. But with substitution, it doesn't matter which variable you get it in terms of. I can add 2y to both sides and say now that x is equal to 11 plus 2y. Now I'm going to take that expression just like I would if it was y equals 11 plus 2x. Excuse me, I'm going to take 11 plus 2y and I'm going to substitute it in for x because now x equals something. Okay, so I'm going to rewrite the equation of negative 7 times 11 plus 2y minus 2y equals negative 13. Now still, everything's in terms of one variable. So I can solve for y. I'm going to distribute that negative 7. I'm going to combine like terms. I'm going to add 77 to both sides. So now I know what y is. Y is negative 4. Substitute that back into the original expression. And x is equal to 3. I know I did that kind of quickly, but we've been doing this for a while now, and I'm kind of hoping fluency is coming, so that it's just a matter of getting some of the new tricks, like putting things in terms of x instead of putting things in terms of y. If you still have questions, please come see me. I will help walk you through this much slower. Okay, good luck.